So hi, I'm Peter. I'm an iOS engineer at Facebook London. And today I just want to talk to you about React Native and try to convince you that writing your next native application in a JavaScript application framework is not the craziest thing in the world. Like, we started this project because we thought native development sucks. Like, there's a lot of cool things you can do, but developing for it can really suck at times. Development can be really slow. Like, if you build our main Facebook application, you make a change, you run it again, you're out for a minute. Like, that's time lost. Deploying your app means you send it to Apple, you wait a couple of days, you get rejected, you wait another couple of days, and then finally you can ship to your users. If you're working cross-platform with teams on iOS and Android, that means you're basically having two teams build the exact same application, but against slightly different APIs, which is a lot of time wasted as well. And that also means you usually have a team for iOS, a team for Android, who both are building the same product, but each of those teams is building the product knowledge on their own, which again is a huge waste. Now you might think, oh, okay, no problem. There's cross-platform tools. I can make a nice cross-platform applications. Well, those suck as well. A lot of them suffer from poor performance. I can usually tell when I'm using a cross-platform application. Like, you can always find out where the UI web view is coming from. Most of them don't support all the native features. Like, they have to go for the lowest common denominator that supports both iOS and Android. And they're usually hard to debug. Like, a lot of them don't come with proper tooling, so it's hard to optimize, hard to know where your users are getting stuck or where they're having issues with. And an issue, like not all of you might realize, that we see in both of them is that they work with stateful mutable UI, which means you, as the application run, you just make changes to the UI so it does what you expect it to do. And that causes a lot of complexity. For example, if you look at a Facebook newsfeed and a network update comes in that the like count is updated, you have to make sure that every single view that is showing that like count suddenly has to be updated. So all these views are now tightly connected to each other. It's also hard to verify that your code is doing what it's claiming to do. You have to basically run through your whole app and check that after every interaction, your app still looks like it should. And then afterwards, once you've got one feature finished and you want to reuse some of it, basically all the views and all that code is tightly coupled to each other. So it's incredibly hard to reuse code. So that's some of the reasons why we started React Native. So I'll go over each of these points again and try to convince you that we basically fixed the problem, sort of. Instead of having a slow development cycle, when you're running React Native, once your simulator is booted, you can just press Command R and your application code reloads instantly. When you got an update for your code, you can just ship it over the air to your users. Apple actually says this is okay. You can use the same tooling, the same APIs for every platform. The principle behind React Native is to learn once and then write everywhere. Not run everywhere. We still want to make applications that feel native to the platform, but know how to use the platform and know how to use the tools. And that means you get teams with a shared skill set that both know the same APIs, can talk the same language. For example, we just shipped Ads Manager for Android after shipping Ads Manager for iOS. And we were able to reuse up to 90% of the code, which is huge. So we don't suffer from poor performance because of a principle called virtual DOM, which I'll explain later. And everything under the hood, once you're using the application, you're using native UI views. So it's indistinguishable from a real app. It is a real app. We also offer a very extensible plugin-based architecture. So anything you want to add in terms of custom views, custom native features, it's super easy to add. And we've invested a lot in getting proper tooling. So you can step through your code, use breakpoints, profile your code, for example, using the Chrome debugger tools. But the most important aspect of it, actually, and this is why it's called React Native and not just JavaScript Native, is because we use functional UI. We use immutable views, pure render function, and one-way data flow, which simplifies the way you create apps tremendously. So 5 core components of React Native are a functional UI using a virtual DOM, a FLEXBOX layout system, and we use a JavaScript frontend, and it all ends up going natively in the backend. So let's start with functional UI and why it matters. So usually when you create UI, you do it quite imperatively. Like, a user clicks a button, you should probably change the color somewhere, probably change something there. But we think we should work in terms of states. Like, either that button is clicked or it's highlighted or not. So an example, like say we're building like this small notification widget. Like you have no notifications, you have 8 of them, something's on fire, you have 99. So if you were to define this using transitions, you'd have to write code to update from the normal state to the state with 8 notifications. And then so we need to add the batch image, we need to set the batch value. In the other case, you need to add the badge icon, add the fire image, set the badge value, and you have to make sure you do everything in the right order, and you clean up going from one state to another. Like in total, if we do this correctly, you need 9 transitions for these 3 states. And like that's a quadratic relationship. As soon as we add another 4th state, you suddenly have to define 16 transitions. So like scales pretty poorly. And if you look at the code that might be able to generate this, like you need at least 7 branches just to define all the transitions and all the possible combinations of UI you might have. Now, if you define this in terms of states, we just have one state for the null state. We have one for the case where you have a single badge. And we have another one for the case where it's on fire. Now, you might think like, oh, so that means we just create a whole new view and throw away the old one every single time? No, that would be incredibly slow. What we use instead is a virtual DOM. Like those who've done web development know that DOM stands for Document Object Model. On iOS, that just means the view hierarchy. And what we do every time you update, we just update the shadow hierarchy, and we make sure we send the most efficient set of changes to native to actually update your view hierarchy. So an example would be, like we have this very nice Christmas tree. I know it's not the time of the year for that, but say we want to just go from this state where we have a right bulb at the top. I want to go to a blue one here, add some other Christmas lights in there. So we can just diff those 2 states, and we get like this small change set. And we can codify that as a communication to the native side saying like, okay, take that view, update this property, create a couple of light bulbs, and make that, insert those in the tree somewhere. And that's all done by the framework. You just describe the states, and the framework will figure out which changes are needed to the view hierarchy. So that's functional UI. Let's talk about layout. On iOS, you typically use AUTORESIZING and manual layout if you're a bit old school, or auto layout if you're with the cool kids. On React Native, we use the FLEXBOX layout system. And FLEXBOX has a couple of principles. Either you position views explicitly, or you infer them from their siblings. Component layout is just completely defined by the container element. So there's no like crazy auto layout dependencies where you depend on your sibling's mother element and there's a 3rd generation dependency somewhere down the line. No, it's just container and children. And everything is basically either laid out as a row or as a column. And this is just exactly the same as the CSS FLEXBOX standard. So you just either lay out, so this is a container element with a couple of children, either you lay out as a row or you lay it out as some columns. And then inside that row or column, you can decide how these views need to be justified. So either they're all aligned at the start, they're centered, they're aligned at the right, or we optimize for the space between or the space around. Like if you've done any CSS FLEXBOX layout, this is exactly the same. And then on the cross-axis or the baseline alignment, we have just the same. You can align at the top, the center, or at the bottom. And this all turns around when you're doing column-based layout, of course. And then the flex value defines how a view basically grows inside the container. If you define a flex value greater than 0, it just basically means fill up the container as much as possible. And if you have multiple children, the relative values of these flex values will determine how big it is. So in this case, we have a container where one element has a flex value of 2, the other one has 1. So this element will take up 2/3 of the view. And flex layout finally also supports wrapping. So if your children are too big for the container element, you can just have them overflow to their next line. Now, the craziest part and the most controversial part, I guess, about React Native is that our front end is in JavaScript. Like, why JavaScript? Why the hell would you use JavaScript on a native platform? We have a couple of reasons. JavaScript is already supported across all platforms, across all the mobile platforms we care about, using the JavaScript core framework. React.js, the JavaScript framework we built is written in JavaScript. And it's also the only option Apple allows for us to ship over-the-air updates. Like, this is something they recently updated in the app guidelines, where it actually allows you to download and execute scripts, but only if they're executed by WebKit. And we checked JavaScript core fits under that definition. But you might say JavaScript as a language is pretty bad, right? It's weakly typed, it's garbage collected, it's interpreted at runtime. Like, why would you want to use a shitty language like that? Well, like, if only like JavaScript, like if a function like this, if only you could annotate it with types like Swift does. Like you could have the polymorphisms here, have higher order functions. Well, actually, this is JavaScript. At Facebook, we've developed a tool called Flow, which allows you to add strong typing and type inference and static analysis to JavaScript. And it really just finds just as much errors in your types as a compiler will. So Flow offers you like type aliases, true classes, maybe types, which is the same as optionals, unions, enums, generics, tuples, mixing, arrow functions, which are blocks or lambda functions, and object destructuring. So it's like a really powerful type engine. The other argument was garbage collection and interpreted code. Like, it's going to be quite slow in the beginning, right? It's going to like randomly lock up your thread because it needs to collect some garbage. The answer to that is async execution. We run all JavaScript off the main thread. That means that everything is asynchronous. But it also means if you've ever done any profiling, if you can keep the main thread free, you got 60 frames per second by default. And scrolling will be super smooth. It has some implications on how you architect the connections between the bridge, between the native and the JavaScript part, but it also gets us a lot of benefits for free. Another part of the JavaScript, so let's look at an example of the JavaScript here. I hope this is mostly readable, but everything is basically, so if we're creating a container element here, and you can just see it's a pure function. We've got the classic hello world here, which is in a text element, which is in a container view, and that's just our component. That's what the render function returns. Now, like this is quite verbose, having to do this React create element every time, passing like random dictionaries around. So we also added something called JSX, which basically allows you to write inline XML in your JavaScript. And this makes it a lot more readable. It allows you to just do any sort of HTML transforms you would usually type. All right, time to go back to Objective-C land, because I don't think we like JavaScript that much. So if you decide to use React Native, the only thing React Native always runs inside a root view, and the root view is basically whatever React Native manages for you. So you can either choose to have your whole application run in React Native, and then you make your root view controllers view, just a React RCT root view, or you can go for a hybrid app, like that's something we're testing right now in our main app, where you just have one bridge and multiple root views using that bridge to go back and forth and manage views. As I said, we also have a pretty solid plugin architecture. There's two types of modules you can write right now, but we're working on more of them. Rich modules are basically a sort of singletons you can expose to the JavaScript, which allow you to invoke random native code. So anything you think is missing from the React Native framework, you can just write your own native module and expose that to JavaScript. The other one is view managers, which basically allows you to insert any custom view you might have, or any view there's not a module for yet, and insert that into your React view hierarchy. So let's look at an example of that. We use macros quite heavily because it allows us to extract a lot of rich type information and basically avoids having to type a lot of like copy pasta. So every native module needs the export module annotation. And then for every method, we just wrap it with the RCT export method. And we will automatically translate that to a JavaScript method name, because Objective-C's naming syntax is not really compatible with other languages. So you can see in this case we have add event location, and that just translates to add event. So in this case, we've built a simple calendar manager that allows the JavaScript side to access the native's calendar API. And we also take care of any type conversion that happens. So we just use JSON over the bridge, so we can use it also with other backend systems. But it means if you want to just have your function take an NS date, from the JavaScript you just send an int, and the bridge, because it knows the types, will just convert that to an NS date for you. Now you also probably want to get information back from native to your JavaScript. But since everything is asynchronous, you can't just return from your method. So one other type of argument you can pass is a callback, or just a function. So for any information you want here, you'll just invoke the callback with the resulting with the information. A quick example of a view manager. So say, for example, you want to have a map view inside your application. You just create a map manager, which is also just a native module. And a view manager basically is a factory for views. So the only method you need here is implement view and return that view instance. That's all. You don't even need the subclass .view to export it. And then from the native side, you can just require a native component with the name, and it will all automatically map together. You can also expose any properties you want on those views to make them settable from JavaScript. So in this case, if you want to enable pitch enabled on the MK map view, you just RCD export view property, which will set up all the bindings. And then on the JavaScript side, you can just access that property now. What we often do is just create another wrapper element for any of these native views, because then you have the type information in JavaScript as well. So in this case, you can see map view has a couple of prop types which explain what properties are enabled to any JavaScript developers. So we talked about callbacks to send information from native to JavaScript. Another method you can use is events, where basically, so in this case, again for the map manager, we make the view manager the delegate of the map view, and then anytime anything happens, we can just send an event to the bridge and let the JavaScript know. Then on the JavaScript side, we'll get all these events, and you can just use a JavaScript Lambda function to make any changes required. Quick note about Swift. Swift sadly doesn't support macros, so a lot of our magic generators won't work. But you can just, for every Swift class you have, if you make it Objective-C compatible, you can just define a bridge module where you just add the mapping, and it will also work. So that was a fly through all the different parts of React Native we have. I added some links if you want to know more. So all of this is open source. We're very active in accepting pull requests or any other improvements you might like. And there's a bunch of really good tutorials out there as well. So try it out.
First of all, what does Facebook gain out of this React Native thing? And I have an app that is core audio intensive. Like it really uses core functionalities of the audio device. How do you go for core native about that or gaming?
So by open sourcing, we get a lot of information back and feedback from the community. And we've seen with other projects, by just open sourcing them, it just becomes a lot richer, and they become a lot more useful than just the things we had in mind. About your core audio question, for anything that you might need native, you can still write those native components, and for any hooks you then need from JavaScript to access that, you just write a native module. So we also, for any complex touch gesture, which you might not support in React Native, you can just very easily still fall back to native and do those things you know that work natively or that are not available in JavaScript just as you would do it normally. Cool, thank you.